Saxon Algebra 2, Lesson 55, Advanced Abstract Equations. Welcome to this very happy place. Abstract, you will recall, are equations that have a bunch of letters in them, and John has to tell us what he wants us to solve for, because otherwise we would have no clue. So here's an example. 55.1. It looks like this. A plus b over x plus y over m equals k. This alone, we have no idea what to do. That's just a big mess. We don't know what we would be solving for. There's nothing inherent in that tells us what to do. So we need John to tell us what to do, and he tells us to solve for m. Okay, that we can do. And we have done these before, so these are just slightly complicated versions of this. We have fractions. You know how I feel about that. I'd like to blow them up. So what we need is a least common multiple with which to explode them. X, m, and nothing. Okay, it's an equation. That means I'm going to find the least common multiple, and I'm going to multiply everyone by that least common multiple. Cancel out the denominators. So in this case, it's mx. I'm going alphabetical. So I'm multiplying each term on both sides of the equation by mx. I'll put it in parentheses so you know I'm multiplying. Okay, this cancels there. This cancels there. And this cancels not at all because it's a 1. So what we're left with, and now I have to be careful here because I've got some distribution craziness going on. So this is going to be m times the quantity a plus b plus, now this I can just multiply straight away, xy equals kmx. So much better, agreed? Now, I could distribute this, but I notice, hey, m's the one that I want to take out. So I'm not going to distribute that because then I'll just have to factor it. Instead, what I'm going to do is I'm going to get these guys to change places. I'm going to switch the xy over there, and I'm going to switch the kmx over here. That cancels, that cancels. I now get m equals, m equals. I'm going to go ahead and distribute this. ma plus mb minus kmx equals negative xy. My idea of not canceling got ruined because we had to combine another guy with it. So I'll have to factor all the m's at once. Okay, and that's what I'll do next. M equals, now I'm going to factor an m out of all three of those, so it's going to be a plus b minus kx equals negative xy. And then we have a big fat dividing to do. A plus b minus kx, a plus b minus kx. That goes m equals minus xy over a plus b minus kx. Now, I look at the answer in the book. By the way, this is a perfectly lovely answer. But when I look in the book, I see that John's got all the signs going in the opposite direction, and that's very confusing. So here's what I do in cases like that. I'm going to multiply the top by minus 1, and I'm going to multiply the bottom by minus 1. That is going to freak out every single sign in the answer. I'm not affecting the m, but it's going to change all of these signs, and let's see if when we do that, it makes our answer look like John's. So m equals, okay, that's going to be a positive xy on top, and then this is getting distributed to everybody, so it's going to be minus a minus b plus kx. And when I look at John's answer now, it's right on target. That's what John has for the answer. All that it means is in different directions than I did when we were up here moving things around. If you gave me this answer on a test, I would give you full credit for it. But as we're working in order to make sure that my answer matches to John's answer, I use this. as my test to see if it actually works. So, either way brings happiness. End of example 1. Ready for another? Example 5.2. Oh, 55. Oh man, aren't you glad we're not at lesson 5? Just think of how far we've come. Okay, 55.2, ready? Solve for x, John tells us. So helpful of him. MP over C plus E plus C, that's a C, over X equals D. Let me double check and make sure I got that right. D plus C. This is actually an E. Okay, I'm ready. We're solving for X. Yeah, there's the X, that's a pain. I don't like my denominators. I'm going to find my least common multiple. It's equal to CX. I'm blowing everyone up by hitting it with a stick of CX dynamite. Canceling, nothing to cancel. Here we go. This is the one now. This is not going to require a distribution. So it's going to be MPX plus, okay, this is where my distribution is. I've got a C left over here, and then my quantity D plus E equals DCX. All right, we'll distribute MPX plus CD plus CE equals DCX. And then we look back to go, okay, now what are we trying to do again? Oh yeah, we're trying to isolate the X. So here's an X, and here's an X. I guess I say let's send him over here because these guys can then chill out here. So let's subtract the MPX from both sides. That's gone. We get CD plus CE equals DCX minus MPX. We will factor out the X, DC minus MP, and then we'll divide that away. And so it's equals X. There's the X. I'm just rewriting it on the other side. And now I'm double checking to the answer. John says DC plus EC over DC minus MP. That looks like a win to me. Perfect. These letters were flipped around in his answer, but in multiplication, order doesn't matter. So we're good with it. Okay, 55.3, one more. Ready? MX over Y. I certainly hope you're writing this down with me and having the fun of following this. Please do if you're not. Right along. It's much less boring to write with me than it is just to watch and listen. That's boring, you guys. I don't want to bore you. Okay, I'm putting him over a 1. I'm acknowledging, oh wait, what are we solving for? We're solving for A. Doesn't really matter what we're solving for. And I notice, oh gosh, Y times the quantity A plus B is our LCM. So here comes our bomb. I write it out by each one because it's so easy to mess this up. Alright, this Y cancels to that Y. This whole A plus B cancels to that whole A plus B. That one, we're stuck with it. So now we go back here, we have MX times the quantity, A plus B. This one's simple, right? It's just dy equals, now this we can just clump the P with the Y and then it'll distribute against the A plus B. So that's the proper way to write that. Okay. Now, we're trying to solve for a, so we definitely have to distribute in order to break that open. So it's going to be amx plus bmx plus dy equals, and now we're distributing, ab plus bp. I like to say my variable clusters, my terms. All right, that's a lot, isn't it? We have 5 terms this time. And we're looking to solve for a, so where are our a's? There's an a, and there's an a. I guess what I for me, I'm going to subtract this amx, and then I'm going to subtract the bp. Let's see what that gives us. That cancels. That cancels. So we have bmx plus dy minus bp equals ap minus amx. All right, let's factor this a out. Py minus mx. And then this is all the same. Oops, bp. And now a big division. Py minus mx, goodbye. Py minus mx, hello. That equals a. I'm going to rewrite the a over here instead of rewriting that whole mess. And now I'm going to check with John. He says positive bp minus this minus that. And then he's got those reversed plus and minus 2. Okay, so it's another one of these days where John swam in the opposite direction. So we have to check. I'm going to multiply top and bottom by minus 1. That means change their signs. So that's going to be, I'm going to move this bp to the front because he's positive now. And then this becomes negative. And this becomes negative. And then I'm going to do the same thing downstairs. He's the negative 1, but he's going positive. So I'm going to move him to the front and then minus py. All right, let's see if this makes John happier. pyb minus mxb minus dy. Okay, that's all correct. Just weird rearrangements. mx minus py. Yay. This is what John likes. This is what I like. They're the same. Both are lovely answers. Oh my gosh. What a drama. It's fine. And we're ready to move on to part B. I can come down a little. Okay. Word problems and quadratic equations is the name of this. That sounds really scary and heavy. Let's just say word problems. We don't need to be dramatic about it. Find 3 consecutive integers. Okay, I know what to do about that. The first one's going to be n. Consecutive integers, so there's no even or odd drama. Plus 1, plus 2. Okay, so there's our 3 numbers, such that this is the first, this is the second, and this is the third. Okay, such that the product, the third, okay, product means multiplying. So the first is n, the third is n plus 2. So the product of the first and the third is, I'll leave out the number, is greater than 4 times the second. Okay, let's try that again. The product of the first and the third is greater than 4 times the second. Okay, cool. We've written the inequality. Now we want to fix it and write it as a proper equation. The number that balances then is 4. This one is greater than that one. I'm going to add 4 to the little guy, and then I'm going to change it to equals. Cool, right? Okay, good. So now we're just algebraing. We set the whole thing up. So now I'm going to do some distributions, and I'm going to get n squared. What the what? Squares. Well, welcome to the brave new world. That's what's happening here. 4n plus 4 plus 4, right? Because that's 4n, and that's plus 4, and then there's another plus 4. Okay, so what we're going to do is we see, oh look, we're getting a quadratic thing up in our bubble here. So let's move everything to the left side of the equation and see what we've got. So this is 8. I'm going to subtract 8 from both sides, and then I'm going to subtract 4n. All right, that takes care of all of that. So this will be a 0. And here we're going to have n squared minus 2n minus 8 equals 0. Does that make sense? We just pushed everything to the left so we could take a look at our quadratic and see, maybe we can factor this by inspection, or maybe we're going to have to break down and complete the square. Heaven help us. It wouldn't be that bad. Secret, I like completing the square, sorry. Okay, let's look at it and see, is there any way we can do it just by inspection? And the happy news is, yes, we can, because negative 8 multiplies by 4 and negative 2 and negative 2 and positive 4. One of those, let's see, which one gives us, oh wait, I did the same thing twice, didn't I? Oh well. Okay, this one, it multiplies to negative 8 and it adds to negative 2. Happy days. So we're going to have n plus 2 and n minus 4. Then we use our factor theorem, our zero product theorem. Both of those names make sense to me. I don't know which one it actually is. But the most important thing is you know that if two things are multiplying and they equal 0, then one of these two things has to be 0. So either n plus 2 equals 0 or n minus 4 equals 0. So n could equal minus 2. I'm swimming that fish in my head. And I'm swimming this fish in my head. Okay, so we have two possible answers for n. And so we have two possible sets of numbers that would satisfy this. The first one is negative 2, negative 1, and 0, right? Because we add 1 and 2 to that. And then the other one is 4, 5, and 6. And I checked John, and he could not agree more. So that is a perfectly lovely answer to this problem. That's the only example for this. As you can see, it's just one of those word problems that we've been doing, but it just so happens that it sets up a quadratic equation in your solution. So that's what we did. We just solved that little quadratic, and life is a happy place. End of lesson 55. Thank you for your attention. Good luck with the homework.